You may have noticed in the last video when we were talking about the um, all of the isomers of pentyl derivatives, I did not one time mention a name. And that's because when we get into larger structures, we have to kind of come up with a convention of naming alkanes. We can't simply give every derivative its own common name. And because of this, there was a committee that was established by the chemistry community called IUPAC. So IUPAC stands for the International Union of Pure and Applied Chemistry. This is a committee that still meets. I think it's on a biannual basis. I know they at least meet once a year, and they discuss, new structures and how we're going to systematically name those structures. For our purposes, we're going to look at fairly simple structures, and so we're not going to get too carried away in terms of naming compounds. But this is how we're going to do it, and this is basically how IUPAC started it. They said, okay, we need some basis names. And they used this straight chain, the unbranched alkanes, as a base. You need to know them. You need to know those straight chain alkanes, right? So first we have methane, which is 1 carbon. We have ethane, which is 2 carbons long. We then have propane, which is 3 carbons long, and butane, which is 4, and pentane, which is 5, right? So that's what we've gone over so far. Methane, ethane, propane, butane, pentane. Well, now when you add a 6th carbon to the chain, it becomes hexane. And when you add a 7th carbon to the chain, it becomes heptane. And when you add an 8th carbon to the chain, it becomes octane. A 9th carbon is nonane, and a 10th carbon is decane. These are the base names. And there are more, certainly. 11 is undecane, 12 is dodecane, and so on and so forth. I want you to focus on these root names because we're going to use them when we apply the rules of IUPAC. What are those rules? Well, the first rule in naming an alkane or an alkyl derivative is to find the longest chain of continuously connected carbons. So this is very important to recognize. All the carbons have to continuously be connected. Now, when you find that longest chain, you find out how many carbons there are, and you use the root word as the base name, right? So if there are 6 carbons, you're going to use hexane as the base name. If there are 8, you're going to use octane, and so on. Now, if all you have is a straight carbon chain, that's your name, right? If you just have 8 carbons, you've taken into account all of the carbons, and there are no branching carbons coming off of it, or no other substituents coming off of it, that's your name. So if I have an 8 carbon chain, its name is octane. And so things don't change that much. However, if there are substituents, what you do is you're going to number the chain to make the substituent number as low as possible, right? So you number the chain, and what happens is you're going to give the substituent a number based on the carbon that it's attached to. If there are multiple substituents, then you number the chain from the end closest to the first substituent. That's the easiest way that I can describe it to you, right? You're not trying to find the lowest sum of substituents. You want to find the lowest first substituent. Then you simply name the substituents and you order them alphabetically, right? So if I have a methyl group and a bromo group, I would name the bromo substituent before the methyl substituent. B comes before M. If the multiple substituents are identical, right, then you're going to use di, tri, tetra, and so on and so forth. So for example, if I have two methyl groups, then I'm going to list them as dimethyl. Now, when ordering alphabetically, you don't use the prefix di in order in the ordering scheme. So if it was dimethyl, I would be basing it on methyl. We also have, can use common names as well. Isobutyl, neopentyl, tert-butyl. And so when we go to alphabetize, this gets a little bit confusing. Iso and neo are alphabetized. Why? Because they are new substituents. Sec and tert are not alphabetized. Why? Because they're based on the carbon that's attached, right? That is secondary or tertiary. So that's can be a little bit confusing at first, but just keep in mind, one way that I remember this is when I'm writing isobutyl, it's one word. There's no hyphen between iso and butyl. It's isobutyl. When I'm writing sec-butyl, it's sec-butyl, tert-butyl. And therefore, whenever I'm using a hyphen, I know that I don't have to use that as in my alphabetizing scheme. So let's take a look at some examples. Here I have an alkane, right? So it only consists of carbon and hydrogen, and I have to find the longest continuous carbon chain. So what's the longest continuous carbon chain? Well, there are 6 carbons here. 1, 2, 3, 4, 5, 6. And so my base name is going to be hexane. Notice on the 3rd carbon, I have a methyl group coming off of it. Now, I could have numbered this going, and one of the things that we have to get used to is how we number. Recognize that molecules are 3-dimensional. So this representation is in 2D and it's stationary, but I could number it starting from the left and working my way to the right, or starting from the right and working my way to the left. If I start from my left, that methyl group, the carbon on it, gets a number 4. And so it's not the lowest designation that I can give it. So this is the best way to number it. 1, 2, 3, 4, 5, 6. The methyl is on the 3rd carbon, and so I call this 3-methylhexane. 3-methylhexane. Here is an alkyl chloride derivative, right? It's one of the pentyl chloride derivatives. And because you see that there are 5 carbons on it. Now, this certainly could be called isopentyl chloride, but that's a common name associated with it. An easier IUPAC name is, again, to use as the base name the longest continuous carbon chain. So I have 1, 2, 3, 4, 5. The chlorine is on the 2nd carbon, and I'm going to name that chlorine as a substituent, a chloro-substituent. So it's 2-chloropentane. Another structure, right? So now I'm getting a little bit bigger. And I have an 8-carbon chain as my longest continuous carbon chain. I have a methyl group and I have a chlorine group coming off of it. How am I going to number it? Well, if I start on my right and work my way to the left, the first location of the first substituent would be on C4. If I start on my left and work my way to the right, the lowest substituent number is C3, and therefore I have to start on my left and work my way to the right. So the methyl group is on the 3rd carbon. It's going to be designated 3-methyl, and the chlorine is on the 5th carbon, so it's going to be designated 5-chloro. Remember, though, I have to alphabetize my substituents. So chloro comes before methyl. Even though 3 comes before 5, we are basing it on alphabetization. So 5-chloro, 3-methyl octane. Why? Because I have an 8-carbon chain. Another example, it's a smaller alkane in which the longest continuous carbon chain is 4 carbons. So I have 6 total carbons in this structure, but the longest continuous carbon chain is only 4 carbons long. Notice in this particular example, it doesn't matter which way I number it, right to left or left to right, the location of the numbered substituents is the same, 2 and 3. So on the second carbon, I have a methyl group, and on the third carbon, I also have a methyl group. So what do? I group the methyl groups together because they're identical substituents. But I still have to give each one of them a location, a number. And therefore, it's 2,3 dimethyl butane. So notice I'm grouping the methyl groups. I'm adding the di, the prefix di, and I simply can group the location of the substituents as well. So 2,3 dimethyl butane. Another example of that is this trichlorinated alkane. Again, the longest continuous carbon chain we have to find, it happens to be numbered like this, right? So 2 is the lowest number that I can possibly get, not 3. And therefore, this is called, so I have a chloro on the second carbon, I have a chloro on the fourth, and another chloro on the fourth. There are 3 of them. Each of them gets a number designation. So I'm going to number it 2, 4, 4 trichlorohexane. And this gives you an introduction to naming. This is how we're going to name compounds. And we're going to see that it's going to get a little bit more complicated as we move on. When you have particular substituents, for example, OH, alcohols, off of the carbon chain, those substituents get priority over other substituents, and we'll talk about those when we explore the chemistry of those functional groups later on. But for now, this is a nice little introduction to naming alkanes and some alkyl derivatives.